Good morning, everyone present here. My name is Kim Hum. Otherwise, I am from second year mechanical engineering. Today, I want to discuss about the mechanics of solids topic on the derivation of expansion of the slope deflection on the cantilever beam of the length L carrying a uniform distributed load of W per unit run apart a span from the three ends using the double integration method. Derive the expansion of the slope and deflection of the cantilever beam length L carrying a uniformly distributed load W per unit second. Run a part of the span of the from the free end using double integration method. Today I want to discuss about the deflection of an cantilever beam about the uniformly distributed load of a part of the double by the double integration method. By seeing of the figure, we can understand the length of the loads of the half of the parts, and the first part is x and another part is 1 minus x. The total load is expanded by here by the slope of the deflection of a cantilever beam as per it enters the length. Consider a section x at a distance x from the fixed ends. Bending moment section by the equation mx is equals to minus w into L minus x into L minus x by 2. But the bending moment at any section is given by equation is m equals to E by I d square by d square y by dx square. By integrating of these, we can able to substitute the equation E I d square y by dx square equals to minus w into 1 minus x whole square by 2. Instead of m, we can able to write that equation of the minus m 1 minus x square by 2. Next, we are integrating this equation e minus ei d square y by dx square equals to mw minus w 1 minus 1 L minus x square by 2. We are integrating this equation. We get ei dy dx equals to minus w L minus x cube by 2 into 3 minus 1 plus c1 equals to w by 6 L minus x cube plus c1. It is denoted as a equation 1. First we want to find out the c1 and c2 in the equation. Again we are integrating this equation. We get e I y equals to w by 6 L minus x power 4 by 4 minus 1 plus c1 x plus c2 equals to w minus 24 L minus x power 4 plus c1 plus c1 x plus 2. It is denoted as an equation number 2. Again we are x, we can able to substitute x equals to 0, dy by dx also equals to 0. When x equals to 0 and y also becomes 0. Applying the boundary condition in equation 1 in e I equals to 0, e I into 0 equals to minus w by 6 into L minus x. From the equation 1 we can, instead of x we are substituting 0. That's all. It comes 0 plus c1 equals to minus wl cube by 6. C1 becomes the equals to minus w by wl cube by 6. Next we want to find out the c2 value. Applying the boundary condition in equation 2, as it is we have applied in the first equation, like that we have to applying the same like that only here. E I x becomes 0 equals to minus w by 24 plus L minus 0 power 4 minus L cube by 6x into plus 2. E- 0 equals to minus wl power 4 by 24 minus wl cube by 6 plus c2. Now we are finding here c2 value. It will become minus wl power 4 by 24 minus L power minus WL power 4 by 8, it becomes the C2 value. Again we are here taking the slope ei dy by dx equals to w by 6 L minus x cube minus L power cube by 6. It is an slope equation. It is considering as an equation number 3. E by I dx dy equals to minus w by 24 L minus x power 4 minus W L cube by 6 x plus W L power 4 by 24. It is an deflection of an equation from the equation 2. We are multiplying in this equation, we get equation number 4. Next we are finding here slope equation theta b equals to slope of the free end b, therefore dy by dx at an from the b. Substituting equation x equals to L in equation number 3 and number 4. We are substituting x as equals to L in the equation 3 and 4. Ei dy by dx equals to W by L minus L cube minus L minus W by L power cube by 6. Slope equals to minus W by L cube 6 EI equals to minus WL square by 6 EI. W equals to W into L. We can able to write W as W into L. E EIY equals to W minus W by 24 L minus L cube WL cube by 6 into L plus WL power 4 by 24. EIY equals to minus WL power 4 by 6 plus WL power 4 by 24 equals to W minus 4 WL power 4 plus WL power 4 by 24 equals to minus 3 WL power 4 by 24. We get cancelled from the third table. It will be 8 minus that equals to minus WL power 4 by 8. We are finding here e power e I y equals to minus WL cube by 8. That we are finding here y value that equals to w equals to minus WL power 3 by 8 into 3i. It is also we can able to find here slope value theta b equals to minus w el square by e 6 ei that equals to w yb equals to minus wl cube by 8 ei. We are find here deflection of the slope of the value of the derived expansion of the slope deflection of an length carried from the uniformly distributed load in the cantilever beam. Thank you. Have a nice day.